Take the number I, the square root of -1. Now raise it to the power I, imaginary base, imaginary exponent. You might expect the answer to be even more imaginary. Instead, one of its values is a perfectly positive real number, 0.207879. How can that possibly happen? The trick is to give I a location. On the complex plane, I sits here, 0 steps along the real axis and 1 step up the imaginary axis. Its distance from the origin is 1, and its angle is pi/2, exactly 1/4 turn. Euler's formula says that a point on the unit circle at an angle theta can be written as n(e to the I theta equals cosine theta plus I sine theta. At theta equals pi/2, cosine becomes 0 and sine becomes 1. So, I equals e to the I pi/2. Choose this shortest principal angle and raise both sides to the power I. I to the I equals the quantity e to the I pi/2 raised to the I. The exponents multiply, giving e to the I times pi/2. I times I is -1. The imaginary units disappear, leaving ne to the -pi/2. An imaginary number raised to an imaginary power has landed on the real number line, approximately 0.207879. But there is a twist, and it is the reason I said one of its values. Angles on the complex plane repeat after every full turn. We can reach I using pi/2, but also by adding or subtracting any number of complete rotations. So its angle can be pi/2 plus 2 pi k, where k is any integer. Using all of those possible angles gives I to the I equals e to the negative quantity pi/2 plus 2 pi k. Every integer k produces a different answer, but every answer is still positive and real. When k is 0, we get 0.207879. Positive k values rapidly shrink towards 0, negative k values grow enormously. So I to the I is not naturally a single number until we choose a branch of the complex logarithm. By convention, the principal branch keeps the angle between -pi and +pi. It selects pi/2, making e to the -pi/2 the principal value. This is not an accident. Complex exponentiation combines rotation and scaling. Here, the angle brings in a second I. Since I squared is -1, that rotational information becomes a real exponential scale. Two imaginary quantities combine, and the result becomes real. What other impossible-looking piece of mathematics should we visualize next?